Hello and welcome to Teen Academy. Today we are doing question 7. We're given a part A and part B. We'll start with part A, and in part A we're given the graph of a quadratic function f with the vertex -2, 5 and a y-intercept at point P. Now for question A, we're asked to find the equation of the axis of symmetry. Now we know that the axis of symmetry is along the vertex, and the axis of symmetry corresponds to the vertical asymptote. So we can look at our vertex and divert our eyes to the x coordinate. Okay, and so the answer to question A is x is equal to -2. And then for question B, we are asked if the function can be written in the form of f of x is equal to 1 over 4 x minus h squared plus k, where h and k are all integers. Find the value of h and k. So we can see that this format of a function is actually written in vertex form, where h and k correspond to the vertex. So we must simply substitute the vertex that we were given along our parabola into the equation. So h and k, h is equal to -2 and k is equal to -5, corresponding to our x and y coordinate respectively. So that is our h and k value. Apologies. Now if we continue on to question C, we're asked to find the y-coordinate of P, where P is our y-intercept. And to find our y-intercept, we first know that x is equal to 0 at our y-intercept. So we can now evaluate our vertex form equation, substituting h and k into our equation, and evaluating for the function at x is equal to 0. And if we evaluate, we'll get, after simplifying, after expanding x minus -2, which is just 0, and simplifying, we'll find that we get 1 over 4, 2 squared minus 5. So f at 0 is equal to -4. So our y-intercept is simply 0, -4. Now we will move on to part B of the question. Now, continuing on to part B, we're now given the same graph with a tangent line L, which is normal to the graph of f at point P. We're first asked to find the equation of line L in the form of y equals ax plus b. So what we can do to start is use point P as a reference. Okay, so we have our equation here, and if we find the integral of our equation, which is, if we integrate our first equation, then we get 1 over 2 x plus 2. We can find the slope of our parabola at point P, which is at our y-intercept, so x will equal 0. And we can find that the slope of our parabola is equal to 1. So then the slope of our line L will be the negative reciprocal of this. So our slope of our line L will be equal to -1. So we can say, therefore, m is equal to -1. So if we want to write out our equation, we can use the point slope form of a line where we get y minus y1 is equal to m times x minus x1, and we can evaluate this at point P, where P is 0 and -4, and then substitute our point and our slope into this equation and simplify and solve for y, so that we find y is equal to -x minus 4. And that is our answer to question D. Now for our question E, it says that the line L intersects the graph of f at a second point Q, as shown in the picture. Now calculate the distance between P and Q. So first off, we don't actually have the point Q. So what we want to do is find the situation where the two equations are equal to one another. So we're saying, when is the equation y, which is the equation of our line L, equal to our the equation of our parabola f? So we'll actually equate the two, where we know that our equation y is equal to negative x minus 4, and our equation of our parabola f is equal to 1 over 4 multiplied by x plus 2 squared minus 5. So if we collect like terms, if we expand and then collect like terms, we will find that our equation should become 1 over 4 x squared plus 2. And then if we factor this, we find that we get 1 over 4x multiplied by x plus 8. And this denotes our two roots. So we'll have the roots x is equal to 0 and x is equal to negative 8. Now we already know our point of x equal to 0 because that's our y-intercept, and that's point P. So the one we're interested in is x is equal to negative 8 because that would be our point Q. So then if we substitute x is equal to negative 8 into either one of our equations, y or f, we can find our y value to get the two coordinates to our point Q. So when we substitute x is equal to negative 8 into our y equation, our equation for line L, we'll find that we get 8 minus 4, which is just 4. Therefore, our point Q is at negative 8 and 4. Now, we can use the distance formula to find the distance between point Q and P. So, using our distance formula, as seen right here, but correctly written down below, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And we write down our 2 points, point Q and point P. And we can evaluate this root. So it actually should be written in the reverse order, but we get negative 8 minus 0 squared plus negative 4 minus 4 squared, so that we get the square root of 64 plus 64, which is equal to the square root of 128, which can simply be written as 8 times the square root of 2. And that will be your answer for the distance between point Q and point P. And that's all for this question.